Welcome to qnawire.
In this question, we have a glancing collision between two billiard balls. Okay, so as shown on the diagram drawn over here. Okay, so and the two billiard balls are identical, and we want to find the speed of v1f. Okay, and the direction of v1f. Okay, so we are given that the initial velocity of v1 is 2.2 meters per second. The final velocity of v2 is 1.1 meters per second at an angle 60 degrees above the horizontal. Okay, so to find the velocity of v1, okay, here we'll be using um, conservation of momentum. Okay, so this is a 2D collision. We'll be looking at, we'll consider the momentum along the x direction and y direction. Okay, so along the x direction, here we are going to write one equation, which is mv1i is equal to mv1f cosine theta 1 plus mv2f cosine theta 2. Okay, so 60 degrees is theta 2, theta here is theta 1. Okay, and here you can cancel the m. Okay, so you have 2.2 is equal to v1f cosine theta 1 plus 1.1 cosine 60 degrees. Okay, or you get v1f cosine theta 1 is equal to 1.65. Okay, so this is our first equation. And then for the y direction, okay, we have 0 is equal to minus mv1f sine theta 1 plus mv2f sine theta 2. Okay, so again you can cancel the m, and then you have v1f sine theta 1 is equal to 1.1 sine 60 degrees. Okay, or 0.55 square root 3. Okay, and this is our equation 2, and so we can do 2 divided by 1. Okay, so we have tangent theta 1, which is 0.55 root 3 divided by 1.65, okay, which is root 3 over 3, and so theta 1 is 30 degrees. Okay, and then v1f would be 1.65 divided by cosine 30 degrees, and we get 1.91 meters per second. Okay, so the magnitude of v1f is 1.91 meters per second, and then in part B, the direction, okay, it is 30 degrees below the horizontal. Okay, okay, next in part 3, we want to check whether the collision is elastic or inelastic. Okay, so to do this, we'll find the so to check whether the collision is elastic or inelastic. Okay, we compare initial kinetic energy and final kinetic energy. Okay, so if they are equal to each other, then the collision is elastic. If not, it will be inelastic. Okay, so we find the initial kinetic energy. This is half m v1i square. So we have half m times 2.2 square and this is half times m times 4.84. Okay, and for final kinetic energy is half m v1f square plus half m v2f square. Okay, so we have half m times 1.91 square plus 1.1 square, and you get half times m times 4.84. Okay, so the kinetic energy before and after the collisions are the same. Okay, so the collision is elastic. Okay, so this is the answer for part C, and that's all for this question.